Okay, today I get a chance to talk to somebody who I actually met ages ago. We have our paths have crossed in a number of different ways over the years, and I'm really excited to get a chance to actually learn more about him and his work and his background. So, with that, I introduce you to the amazing Eric Singer. Hey, Eric, how's it going?
It's going well. Thanks for the introduction. And yes, many ages. I'm not sure how many ages.
It was a long time ago. That's a fact.
Yes.
So let's start off by having you. I would sometimes I talk about people's work. In your case, it's such an extraordinary body of work. I don't even want to jump into it. So instead, I'll let you give us a quick tour of what you consider your artwork.
A big and broad subject, especially when speaking to an easily distracted type A personality like myself, with far too many interests. Mostly what I've been known for, the kind of most notable thing that I've done over the last decade and a half or so is to create robotic musical instruments. And I started that in New York by creating a group called Lemur, League of Electronic Musical Urban Robots. And that was in 2000, and really got a bunch of people together and said, "Are you interested in making musical robots?" And they said yes, and that's what started that. So that's my more recent history. Going back before that, I was making and performing on strange electronic musical instruments, making a lot of different MIDI controllers. One of the first ones that I ever put a video online of was called the Sonic Banana, and it was very simply a rubber tube with 4 bend sensors in it. It sent MIDI controller data, but really the data was kind of meaningless until you ran it through software. So I was using Max MSP Jitter, which was just Max MIDI back then,
right?
And generating sounds using algorithms inside of Max. So kind of started creating MIDI input devices, and then flipped the coin and started making MIDI output devices. But also along the way, I have done work with interactivity, interactive video, and music, generative music, a little bit of algorithmic composition stuff. And as a kind of parallel project that I was doing in New York at the time, where I was from 94 to 2009, I co-founded an art group called the Madagascar Institute, and that group was dedicated to things like guerrilla art, street theater, fire art, machine art, anything kind of like dangerous and subversive, with a scoop of Burning Man thrown in. That fairly encompasses things, I think.
Yeah, I think so. The one thing it doesn't actually, to me, encompass properly is that a lot of what you talk about sounds like what we think of as kind of like maker art right now, except you predated this stuff by a full decade to a decade and a half. You were doing this stuff long before anyone thought of, or I think before it was common to think of like, well, I'm going to make my own damn input thing, and then I'm going to make some software, and I'm going to use that to drive musical instruments. I mean, at the time that you were doing it, it was pretty awe-inspiring because it was so unlike what people were doing at the time, right?
This has been my curse throughout life. I'm always there doing something
a decade too soon, right?
Yeah, and then when I kind of finish and move on to the next thing, it gets a name and it becomes really popular. So, I can't tell you how many times that's repeated. I mean, I was a maker before there were makers.
Right.
You had a
maker space before that was even a thing.
I did. Yeah. I mean, Lemur Plex, where we had our shop and teaching space and performance space, was kind of a nascent maker space. And certainly, but virtue of the fact that we were building all of our instruments there, and we had a machine shop and electronics shop, you would certainly call it a maker space now.
Right.
But again, that term didn't
have a name at the time. Yeah.
In 2006.
Yeah, I remember actually coming there. I played a gig there after an AES show one time. I was there with Brad Garton and that crew, right? Greg.
Oh, right, okay.
And I remember walking in the front door, and right above my head, there was like a drum with a robotic beater just kind of going bonk, 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 bonk. And walking in and looking up at that, and just like, oh, this is a place, right? It was like, for someone who is like into sort of like geek music, tech stuff, it was like, oh, I just walked into Nirvana.
All right, glad to hear it. Yeah, I like to kind of put things everywhere and just keep making things and putting them and making and putting them. I like the surround effect of having musical automatons and robots kind of distributed around a space. So I kind of really screwed myself into an aesthetic of having to get up on scissor lifts and very high ladders to hang lots of instruments from ceilings. So yeah, floor, ceilings, walls. The place was pretty well covered. We did a lot there. It was exciting. I mean, residencies, teaching classes, probably 50 or 100 interns and apprentices came through there.
Over the years,
a lot of people learned machining. A lot of people learned electronics. A lot of people composed and performed there.
Yeah, it was. Well, and what's interesting is that was like in Brooklyn before Brooklyn was cool too. I mean, you were on the front end of frickin' everything. It's unreal.
Yeah, now I see it. Now I really sound like a proto-hipster.
Yeah, you do.
I once said to a friend, like, I feel like I'm saying, oh, I was doing that before anyone else was too often. And she said, yeah, but it's also true.
Yeah, right. Exactly true.
Not looking for bragging rights or anything, but it is that kind of thing. Like, I can't explain it when I'm doing it, and then a few years later, there'll be a word for it, and then I just have to say maker. So,
right.
I had a maker space, but it wasn't maker space when I had it. It was
right.
This other thing, yeah.
Yeah, now I think if for people for whom this sounds maybe somewhat familiar, they probably know you from some of your best known robotic pieces. And certainly one of them that got the most attention in the musical sphere was your work with Pat Metheny on the Orchestrion, right?
Yes, Orchestrion.
Or Orchestrion. I always say that wrong. What was sort of like the lead into that? Because obviously, Pat's not going to put his reputation on, I think a guy might do a cool thing. You obviously had some stuff that led into that. What was sort of like the lead in that put you in a position to be able to take on something with that high of a visibility factor?
Well, see, he contacted me first in 2008. We spent 2009, almost the entire year, building this giant collection, and then he spent most of 2010 touring with it. Mm-hmm. But prior to that, we had built so many instruments and so many installations, and he had seen a lot of that in videos, and he'd seen some stuff in person, perhaps installations or maybe performance here and there. But I don't actually at the moment remember, exactly where he saw the stuff, but there was definitely video online at that point. So,
okay.
he kind of knew what I did. He knew what instruments he wanted to have created, and we talked about it. He said, I want this 40, 50 instrument robotic orchestra, and I said, yep, we can do that. And which is a really dangerous thing to say.
I was gonna say that sounds like an insane man talking, quite frankly.
Well, another curse is that I find myself very often doing things that I have no idea how to do,
right,
and then just figuring it out on the fly. So I put on big concerts, I put on conferences, fire arts festivals, and all of this stuff just started with this motivation, like it would be good to have this thing, and I guess I'll have to do it then if I want it to be reality, without kind of thinking through, we're going to need a whole crew of these people, and it's going to take this much money and that kind of stuff. I sort of like just dive in most of the time and then figure out the details. So, I mean, if you don't challenge yourself in that way, if you just do everything that already know how to do, you're not going to move forward. I have a tendency to stick my neck out. I have at times paid the price in terms of unbelievable amounts of stress in fulfilling a deadline. The next really big project after that, which I moved to Pittsburgh in 2009 and continue this work under the title Singerbots because I don't have the group together anymore. So the next really big thing I did was another Orchestrion for a cabaret theater in Paris. And again, that was another thing where I had to build, and I hired people to help with this, but we had to build a ton of stuff in way too short of a period for a show must go on situation. So nothing like a deadline to motivate, right?
Right, sure. Well, I think one of the things that I would say, and my first experience with it was walking into the Lemur Plex back in the day, but having kind of encountered a couple of pieces of your work, both online, in online video, but also a little bit in real world, there is something very peculiar and very particular about the combination of the mechanical robotic music making device, but the fact that these are actually acoustic noisemakers rather than electronic music, it really tends to sort of blur some lines in a very significant way, because you kind of get the sense that this is sequenced material or that this is highly orchestrated material, but there's it can be
not always
right, but there's also sort of something that is very organic, and I don't know, and maybe you can fill me in. What is it about it that feels different? Is it just the fact that in an array of 50 actuators or 50 relays, each one might activate at a slightly different timing, or is it just the way that we viscerally react to acoustic sounds versus electronic sounds? What do you think makes for such a different experience in listening to this particular implementation of a music making device or robotic band in essence, right?
You just made me think of something funny, which is, I guess the variations in the robotic mechanisms make the instrument sound more human.
Right. Yeah.
There's a weird accident.
It's the mechanical equivalent of creaky knees for a drummer, right?
Yeah, I guess. But really, I mean, the main point really is to create acoustic sound and do it under the control of a computer. So you have, you now have all of the tools for composition, for software generated music and for interactive installations, and the sound that's being produced is one more organic, because sound that comes from real instruments and interacts with the space is almost without exception more, quote, organic sounding, more real and live sounding than sound coming out of speakers. Mm-hmm. And if you walk into a room with your eyes closed, you can almost always tell if you're hearing a live band or if you're hearing a recording. It's just the way that physical sound interacts with the room. It's not coming from those right. 2 point sources.
Sure.
And then again, also with synthesized sound, for the most part, when someone creates a patch, someone creates a sound on a synth, every time you play that sound, it sounds exactly the same. But that's not kind of, real life. Just some of the things we enjoy about music. Even a drummer, playing a beat on a ride cymbal, every hit is going to have a very slightly different sound. And so that, you kind of get that for free in that we didn't have a, $500 million machine shop where we could manufacture things to, aeronautical specifications.
Right.
So it's always been the best I could do with the tools that I have and the amount of money that I have to spend, or sometimes a little more than the amount of money I have to spend. That's another thing. But so, there's that. There's the idea of surround sound and not having to fake it with speakers. And I'm not against that at all. I mean, I think multi-rate speaker things systems are cool. And I'm about to start playing around with a quad sound thing and processing saxophone and having it spatialized through speakers. Mm-hmm. Anyway, it's slightly off topic, but and then making all of the instruments be MIDI devices means that anyone who's used a computer to make music already knows how to use them.
Right.
They all respond exactly the way you would expect them to in terms of what happens in the computer and what comes out of the instrument. So a xylophone is going to have all of the MIDI notes of a xylophone mapped to the beaters corresponding to each note, mm-hmm. and the software or the firmware in the control box takes MIDI in, reads it, interprets it, and turns it into signals to the mechanics. So as a composer or as whether it's a scoring composer or an improvising composer or an algorithmic composer, you don't have to think about the mechanics at all. You just think about making music.
You think about the composition, right? Yeah.
Yeah, and that was kind of self-evident to me that they had to be MIDI instruments when I started making them. Prior to that, though, prior to MIDI, which I think is the most successful interconnecting standard for computers ever, and the most reliable, that they all had to be MIDI. And as I was saying, prior to that, you didn't have a lot of standardization. So if someone was creating some kind of automated musical instrument, you might have to write software for it. And in fact, even for synthesizers, before there was MIDI, there were some standards back in the analog days, like 1 volt per octave, and being able to patch control voltages around 1 to 10 volts maybe. So you could theoretically patch from one keyboard or one ribbon controller or something like that into a different synthesizer. But when you start coming to digital systems, if you're not following a standard, the brilliance of MIDI was this: we had all of a sudden a standard way that musicians could make take control over electronic sound. You didn't have to be a keyboard player to play a synthesizer. And you don't have to be a keyboard player to play any of my instruments. You just need to be able to get those notes into the instruments, out of the computer or out of a controller or whatever's generating the MIDI.
That's actually really an interesting point, because I think so often people think of MIDI as a way of producing sounds from a synthesizer based off of a keyboard or something, but really what you used it as, and what kind of an abstract use of it is, it's a descriptor for talking about the notes that you want played or the function you want assigned to a process, right? It's a description a lot more than it is a description of an event, more than it is a keyboard oriented or a synthesized oriented message.
Yes, but that event is still the note that you requested the instrument to play by MIDI, just as if it was a synthesizer. So that makes it really easy for anyone who's used synths to do the same thing,
right.
With the robotic instruments. So, in one sense, out of the box, they work just like synthesizers, just like you'd expect a synth to work. Mm-hmm. Sometimes, a lot of times I'm using MIDI simply to pass data around that doesn't necessarily have musical meaning. Like, for instance, I can tweak all of the software parameters on any of the instruments using a max patch, and that patch is sending system exclusive MIDI sysx messages that I've encoded to be meaningful to the robots, and that way I can adjust all the parameters. Those get stored in memory persistently, and so now I'm able to kind of tweak all of the instruments and dial in stuff using software instead of always having to adjust hardware.
Got it.
So, I use it for that. And then the stuff that I was doing before the robots and still continue to do before I got on the phone with you, I was working on a new MIDI instrument. So I still do that, still create musical or MIDI controllers. A lot of times those controllers are outputting MIDI data that is meaningless if you were to plug it straight into a synth. It's just sending me control data or pitch bend data if I want higher resolution. Mm-hmm. And I'm taking that into a software program. 98% of the time that program is max, and doing whatever I want to do with it to create sound.
Got it.
So, for instance, the Sonic Banana was for MIDI controllers. So it's just sending MIDI controllers 1 through 4. That's not going to get a sound out of most synths.
Right.
So into max it goes, and then I used it to. First thing I did was create an arpeggiator and use each sensor to map to parameters of the arpeggiator. So one of them was speed, one of them was selected the chord that was being arpeggiated, one was pitch bend, one was note duration.
Okay.
And then I could map them in all different ways.
Sure.
And that also then leads to, and we might not want to jump here right away, but it leads to this interesting idea of the fact that when you create electronic instruments, you're divorcing the physical actions from the sonic results. A violin, pretty much every time you pick it up and run the bow across it the same way, you get the same sound out of it. If you picked up a violin and every day someone had messed with it and, flip the strings around, put different kinds of strings on whatever. And those are just the simplest kinds of things.
Right.
One, it creates this incredibly versatile instrument. And two, you become a novice each time you pick it up because it's changed.
Right.
So that's something I struggle with a lot. And I talk to students about when I'm teaching, and, how can you become a virtuoso on the Sonic Banana? How can you, become an expert rubber tube player, especially when the software can be changed at any time. So sometimes I will fix the software and say, this is how this instrument is going to work, at least, for the month of January.
Right.
And then
Sure.
Can do that. And I've made some instruments that I intentionally created that could just send MIDI out to a synth and be played, basically kind of be used to jam with a band that has actual humans playing actual instruments that are using Western scales, but have an improvisational MIDI controller that could play in particular keys and wasn't just making abstract sound and stuff like that. I'm not against abstract sound either. I'm not against anything.
Well, but I'm curious about this because it's clear that you're combining a lot of skills to do the things that you do. You have obviously a deep interest in instrument building and musical composition, but you also seem very clearly to be completely at home with a machine shop and a press brake and a drill press. And one of the things I like doing in my podcast is exploring people's backgrounds and kind of how they got to be the artists they are. And in your case, it seems like, first of all, how do you get to be a person that has a skill set in all these different areas? But also, how did you get to the point where you were the guy that was a decade ahead of everyone? Where were you coming from at, it could be Mars. So I'm a little bit curious.
I don't know that it would be fair for me to be the one to answer the second question. I'm just kind of too busy doing the stuff to figure out its place in time and history. But, the way I came to doing all of the kinds of things that I do is it really starts with, as a kid, growing up with a love of engineering, especially computers and electronics, and the love of music at the same time, and never being satisfied just being able to do one or the other. So although my first degree, my undergraduate degree, was in computer engineering, any chance that I got, I would apply that to computer music stuff. Also, on the other hand, I was just playing sax and swing bands and combos and things like that, and a lot of ska music along the journey. But stuff that having absolutely nothing to do with electronics, just having to do with music.
Right.
But so to me, music and engineering is one really cool intersection. I think that, the most interesting art and the most interesting invention is in the intersections between different subjects. And I think makerism is something that exploits that a lot. You get two people with two different backgrounds in the room and start talking, and they're like, what if I combined my chocolate with your peanut butter? And, you get a Reese's cup. So that sort of thinking. So some of the early MIDI instruments I made were exactly this idea of looking around, seeing something laying around and going, how could I turn that into a musical instrument? And that means electronics, usually, though there are, people like Mark Stewart from Bang on a Can that make tons of acoustic instruments. And I'm trying to think of some of the other guys. There's a couple of guys in New York. There's people all over the place, of course, creating so-called experimental musical instruments, though I don't like the term experimental, because we're not all experimenting, we're creating.
Right.
So it can be done with acoustic instruments, but my interest was in bringing my engineering skills into it. And then as far as all of the other skills that I picked up along the way, that's been like a combination of an interest or fascination with a subject and an obsession with being able to do it. So when I decided to start creating robotic musical instruments, when I wanted to pursue that, I did not know anything about robotics. I didn't know anything about machining. But what a great way to learn something is give yourself
a project, right?
Put that project out in front of you and figure out how to get it done. And I just happen to be a very DIY personality, definitely at times to my detriment. I must do this thing myself now. Few trips to the ER later. Learning to be able to do this stuff with robotics, I had to find people who could teach me this stuff. A lot of the stuff you just couldn't. First, there was no internet, and then the internet didn't have Instructables and Make Magazine and all that kind of stuff online, and a million blogs where you could go find out, like, I want to make X, and you Google it and you find 10 or 1,000 different versions. Then, of course, leading to the, oh, great, someone that's already done this before.
Right.
As far as learning skills, it's a lot easier to do it now. Well, I mean, it's easier to find sources to teach yourself how to do things. Learning any skill is however hard it is to teach yourself the skill and to learn the skill.
Right.
And definitely when I started out machining, I was a crappy machinist because of course I was. I didn't know, I didn't even know what what shop equipment could do for me, what I could do with it. I more had the idea that the first idea that I pursued was the Guitarbot, robotic slide guitar-like instrument, not actually made of a guitar, but uses guitar strings.
Right.
And I had this idea that I wanted to make this slide, that I wanted to have a slide mechanism on it. It took 2 years of learning before we had a prototype done, learning and experimenting and creating and going back into the loop and changing things and all of that kind of stuff. So, it starts out, someone taught me, oh, well, here's an irregular shaped piece of metal. Now you can use a milling machine to make it square. Great. So now you can go from like a chunk to a cube. Well,
right.
Now what can you do next? Oh, well, I can make a slot. Great. Well, that means I can make a mechanism that moves in a slot. And I had some people early on say, when I was sort of lamenting the difficulty of learning machining and learning robotics, they would say, well, why don't you just design things, have someone else do the machining?
Right.
I said, because I don't know what the machines do yet.
Right.
I don't feel like I can't explain to someone how to make what I'm thinking because I don't know what's possible yet. And that's always something that's, I think, really helped, really informed my work, is learning these skills and exploring new skills and having goals and not having the straight path to get there and seeing that straight line. But, okay, I want to get from point A to point Z. Where can I go from point A? And, this whole kind of long weaving journey, and your result at the end may or may not resemble your goal at the beginning as you learn things about capabilities, what's possible, what's not possible.
I was just going to ask about that, because I would think that if you're coming at like some of this machining stuff from kind of a naive point, it really could be a thing where there's a give and take between what you imagine doing, and then all of a sudden it's like, oh crap, I didn't know that I could drill a square hole. That's really a thing? Oh my God. And then all of a sudden that changes your perspective of what you might create in the first place.
Yeah, absolutely. There's two extremes. One, there's learning how to do something and then doing what it can do, and then the other is wanting to do something and learning the things that you need to get it done,
to accomplish it. Right.
And I work both ways. Sometimes I've got a gizmo, I've got a new electronic sensor, I've got something, and I go, all right, well, this is cool technology, let's turn it into an instrument. Other times it's, I have an idea for an instrument, what do I need to build it? And, that goes for any kind of invention, that I make or that anyone would make. Sometimes it comes out of discovering capabilities, sometimes it comes out of an idea, and you learn what you need to hopefully be able to accomplish it. One of the first problems I had, and it was just even a conceptual block, was how do I attach something to a motor shaft so that something can spin? Mm-hmm. Suppose I want to make a pulley spin so I can make the slide go up and down. Mm-hmm. At the beginning of that, I have a shaft that's 1 millimeter in diameter, and I've got a hole that's 5 millimeters in diameter. So what the hell? And seriously, I was confounded by that in the beginning. I was like, I can drill a small hole in this thing and smush it onto the shaft and whatever. Now I know all the techniques to do that stuff, and I've mastered searching the McMaster-Carr database to find the stuff that I want. But, when I started out, I didn't know what the numbers of screws were and what the sizes and, what they meant. So it was a lot of hard work, but it was all incredibly fun because, now, this is how machine screws work. Oh, well, all I ever saw was a bolt and a nut. Oh, there's a million different kinds of nuts. Oh, there's a million different kinds of bolts. All of these things. And, McMaster, which is one of the biggest industrial supply houses, for those who haven't heard of them, that's where I and many people get a lot of their parts. And that is everything from motors, pulleys, machine tools, mill bits, drill bits, everything. So before they had a easily searchable internet site, especially because they were around long before the internet, they had a catalog, and that catalog was about 3 inches thick, maybe, about 5,000 pages of densely packed industrial equipment. So if you think, I need a screw for something, you're going to find several hundred pages of screws, and you're going to slam the book closed and go, oh my God, what have I gotten myself into? Then you open it up again and you start to go, okay, well, 90% of this stuff I've never seen anything like before. It's probably not what I need. And you start kind of paring it down from there.
Right.
Then once you understand the basics, then you can sort of intuit sometimes when you need something that you haven't used before. It's like, I need a screw that just has threads on the end so I can have something spin in the middle. Is there such a thing? Well, yeah, there is, and it's called this, and you go out and find it. So, you learn some, and then you intuit some, and then you learn some more, and you intuit some more, and then you gather this, body of knowledge.
Right.
And then you put it together, you gather the body of skills.
Right. In addition to all of the ability to create these physical devices, you also kind of from scratch, I think, would have had to have built all of the electronic and the computer interface tools. I mean, using MIDI is great, but it's not like when you started this, there were, you could go over to your local hacker's shop and pick up an Arduino and a MIDI shield. I mean, none of this stuff existed at all. And in fact, you talk about kind of doing it before the internet was much of a thing. I mean, I remember back in those days, it was freaking hard to even find a way to get your hands on the MIDI spec to even know what the hell was going on.
When I was a kid, if I needed a resistor, I had to walk 10 miles in the snow, uphill, both ways.
Both ways.
Just to get to Radio Shack and find out that they didn't have it in stock.
Yeah, right.
Well, I mean, the way now you can get anything in Amazon on Amazon in a day or two, or from anywhere, DigiKey. Back then, you had to, if you really wanted to do this stuff, you had to outfit your own lab. You had to outfit a shop. You had to buy some of almost anything you were going to need to use to work on any particular day. And, anything exotic or anything that you're doing multiples of, you have to have some lead time. But just to have the ability to experiment back then, you just had to have a ton of electronic parts on hand.
Right.
And even with robotics, had to have a ton of raw materials on hand. So I always have, rods of aluminum and steel in all sorts of various shapes and profiles, things like that, because if I absolutely have this idea that must be done now, I have to be able to get the thing off of the shelf and start making it. So, it's much easier now than it was back then. But I'll tell you about the first electronic instrument or instruments that I built. The first MIDI instrument that I built was a MIDI saxophone. And this was as an independent study project for Roger Dannenberg, who is a professor at Carnegie Mellon, was my first computer music teacher. He's an utter genius. Look up his stuff. He's invented tons of stuff that you use, including Audacity, and really brilliant stuff. So I made a saxophone-like instrument using a bunch of switches that were mounted on a block of wood that I had carved in his basement. And then I got a pressure sensor from someone at Carnegie Mellon. I don't know who it was, but the thing was about the size of, it was probably about 3-4 inches square, maybe an inch high, and that was a single pressure sensor. Now you can lose pressure sensors in the carpet; they're so small.
Right.
So I had that for the pressure sensor, and I wanted something to do reed pressure sensing, because on sax you do pitch bend basically by squeezing harder or less hard on the reed. So I wanted to pick up that pressure as well. Couldn't find a pressure sensor, so basically built my own sensing device with an LED and a photo sensor and a little wedge that would block the light the more you bit down on the reed.
Okay.
So now I've got all the electronics and I got it all wired to a connector, but there are no Arduinos. There are no basic stamps. Right. There are no PIC micros. There are things like 6502s and 68000s and early microchips.
Right, yeah.
Right, and they have little windows on them so you can erase them, and you need a special burner to put the code onto them. That was actually probably my second generation of instruments where I went to that stuff. But the first one was actually done using an Apple II computer as the brain. And so that saxophone was interfaced to a plug-in card for the Apple. And that was a great thing about that computer, is it's very open. It had 6 or so card slots for peripheral cards, and you could buy a blank one and put your own stuff on that. Instead of breadboarding, instead of soldering back then, I'm dating myself severely now, one of the easiest tools was wire wrapping, where you take this kind of spinning drill type tool, you stick a wire in the end, you put it on a long pin, the post, a particular post for the IC, press the button, and it wraps the wire around it real tightly. And then you take it to the next point and you wrap another wire around. So that's how I made a plug-in card for the Apple. And then I pretty much needed to do the programming in assembly language, which was 6502 assembly. So you break out of the basic shell and into assembly language, and now you're writing machine code. And so from a technological standpoint, it was brutal. Kids today, man, they have it so easy. I love where things have gone. I could never have imagined it. I don't think anyone could. That, for literally for $5, I can spend $5 online, and tomorrow have a computer that's, it sounds so cliche, but it's like a computer that's the size of a postage stamp and has more power than the ones that launched the first moon mission or whatever. Right. It is, the prices have come down so incredibly far, like further than I could ever imagine, and the complexity has gone up kind of in a way further than I could have imagined. And it's a great time to be interested in this sort of stuff, and it's a great thing to be interested in. Go makers, STEAM education, all of that kind of stuff. In one sense, I wish that existed when I was a kid. In another sense, the future never exists when you're in the past.
Right.
So you work with what you've got, and the best stuff is done by working with the limitations of what you have and pushing it out as far as you can and pushing it in different directions.
I'm kicking myself because we're already out of time, and I almost want to make this a double episode because I have such a list of things I want to talk about here. But
you can call me next week for part B.
Yeah, I think maybe we're going to in fact do that. But what I want to do is I want to pick up on that thread because of one thing. I mean, we talked earlier about how you were the guy that was a decade ahead of things even getting a name, right? How do you sort of maintain the front edge of that wave? But also, the other thing that you mentioned that I'm really curious about is the fact that you have had a ton of interns, a ton of students. They get experience working with you on this stuff. How do you also put them in a position and transmit to them this idea of don't be satisfied with the thing that you can get from Amazon for $5. Push the envelope. What does pushing the envelope look like when all of this stuff seems, on the surface at least, to be so freely available?
That's an interesting and broad and abstract subject. One, how do you surf the edge of the wave if that's what you're driven to do? Mm-hmm. One thing I say is I've never had a shortage of ideas, but most people don't have a shortage of ideas. It's actually sitting down and doing things that is 95% of the job. I think ideas, for the most part, are a dime a dozen. I don't agree with the patent system because the idea that you can come up with, you're just the first one to get this idea patented, and you're not very likely not the first one who thought of it, and definitely not the person who can actually create it. I mean, sometimes you are, but a lot of times people will come up with an idea they think is original, patent it, and then no one else can do it.
Right.
And they can sit on that. That's my problem with kind of big idea people. You don't necessarily have to have the skills yourself, in which case you have to have the ability to collaborate and to find collaborators for the things that you don't know how to do or aren't good at. For example, if I'm doing video, incorporating video into my work, I'm usually getting someone else, collaborating with someone else who is a better video programmer than I am. I think to stay on the cutting edge, your creativity will generate these ideas. But the fact is, the guy sitting on your left and the woman sitting on your right also have that same idea. And one of the three of you is actually going to get up after the lecture and
do something,
go buy the parts
right.
And make the thing. I work all the time. I go to a day job, I come home, and then I work on my own projects. And it's because I love it. And that's, I think, a key to my personal success. And I'm just talking about success in terms of being able to do and make the things that I want to do.
Right.
Has been an obsessive drive to do it. It's to get an idea and hold on to it, and not be able to shake it off until I've built the thing. or I built something that sprang from that idea. As far as, inspiring other students and makers and artists, I think showing them what I've done, explaining how in the past when I did have interns and apprentices, getting them involved in actually doing things and not just busy work, but meaningful work, and also imparting to them skills and knowledge that they are probably not going to get elsewhere. After being around for a while, it became known that Lemur was a real cool place to do an internship because, you weren't getting coffee and you weren't just like buffing metal.
Right.
You were getting me and some other brilliant people who were top echelon of Lemur hanging out with you and talking to you. And if you had an idea for a project or you were stuck on something, people who would be happy to volunteer their information or their skills. And I've always felt very responsible to anyone who is doing anything for free for me, that I need to pay them back in terms of knowledge and skills. And there was this period when if you wanted to learn machining but didn't want to go to a Votech school,
trade school
for auto repair, there was almost no place to do it. When I started out, I found a course at MetroTech that I could take as, a non-enrolled student. Fortunately, I also at the same time found a guy with a machine shop who could show me some stuff. But then there was this period where we were churning out so much stuff, and we had pretty well open doors to anyone who would actually show up and work, that, you were going to come in on a Monday and then by a Friday, you're going to know how to use a milling machine. You're not going to be an expert at it, but you're going to know, you're going to understand this really daunting, huge, heavy piece of equipment that the first time you looked at, you're like, what, how?
I have no idea. Right. Yeah.
Right. Or, you heard that a milling machine can cut metal in all different ways, but it's got, 20 different knobs and handles on it and 3,000 different tools you can put in it. How the hell do you get anything done?
Right.
Well, you start out by breaking a bunch of stuff and then you fix it or you buy more and you learn. Don't be afraid to screw up. Don't be afraid to break things. These are all kind of cliche things, but that's how you learn. That's how makers operate, how makers are doing so many incredible things. It's not even necessarily that everyone's got, the brain of Einstein or let's say Tesla and, a ton of, and a brilliant invention springs forth from their head every day.
Mm-hmm.
I think it's more so having a want or seeing a need that needs to be filled and deciding, do I have the skills? Do I want to acquire the skills? How can I acquire the skills? Oh, there's the internet. I just Google, and then you either do it or you don't. And I think that's, what do they say? 10% inspiration, 90% perspiration, right?
Right.
I'm going to pull out all of the cliches.
Well, but I mean, they certainly do work, because I think that you are a great example. You're a great exemplar of this idea of ideas might be a dime a dozen, but implementations are really hard to come by, and one of the things that you have always done is been an implementation guy. And I think that is what points to the amazing body of work that you've put together. Why having you as a guy that's teaching is such a wonderful opportunity, and why now we get to go to your website and see such a collection of jaw-dropping work. I think it's living those things rather than just saying them that makes it so.
Yeah, that's a good way of putting it. I hate sitting around doing nothing.
There you go.
So my worst skill is relaxing.
Now that I completely understand. Well, Eric, I'm afraid that our time for this round is up, but I'm going to take you up on this idea of calling it, because I really want to get into some. I mean, when you start talking about the range of things from fire art to Pat Metheny, I mean, we have a bunch more ground to cover. So I'm going to take you up on the idea of calling for a second run through on some of this stuff. But in the meantime, I am going to let you have the rest of your evening. I want to thank you so much for taking the time to have the discussion with us, and for letting us into a little bit of your thinking and your approach to the world.
Well, thank you. This was a lot of fun. I love talking about these subjects, and happy to do it again.
All right, sounds great. Well, with that, I'll say goodbye. Have a good one.
All right, you too.
Well, that was a ride. Thanks to Eric for having the chat. It was a lot of fun. We are going to pick this up with a second one next weekend. We're going to learn a little bit more about some of the individual devices that he created, as well as some of the background behind the Madagascar Institute and some of these other things. So stick with us. We're going to kind of further the run on this next weekend. I want to thank you, the listeners, for continuing to show up. Thank you so much. As we get to the end of this year, I hope that you're taking the opportunity to reflect on this last year, and that you're taking the opportunity to thank the people that you love and that helped you, much as I would like to thank you. So have a good one. We'll catch you next week. Bye.